So we're going to wrap up the last bit of histogram stuff that we didn't get to do in class. So we've talked about this already, that discrete data was our specific data, specific values, like our example were shoe sizes. Continuous being that basically every value is possible. Think of it like endless decimal places, right? We talked about this being like measurements of length and time. We talked about how to measure center, that mean is average, right? And it's not affected by our extreme values. It's not resistant. Median was the one in the middle. When we have an even number of data points, we average the two in the middle together. Mode is our one that happens most often. And then we started talking about actual histograms and what they look like and how they were basically frequency graphs and how they can show relative frequency or they can show just regular frequency. Like I said, we took a lot of notes on this on class. So if there's something about these things we talked about in class that you're not understanding, make sure you come on in and ask your questions or come to tutoring because we're going to jump straight to how to build it. Okay, so this is where we had ended up. We had decided that our bin sizes were going to go by 20s, and we had gone ahead and we had made our frequency table. Looking at our data, we had counted how often we saw data points that fell within those certain ranges. And we had started to set up our histogram, right? Remember, our y-axis will be frequency, and our x-axis in this case is going to be our number of US medals. Okay, so when we set this up, we're going to need to set up our scale on both the y-axis and the x-axis. So going up the y-axis, our highest number is 9. So we should be able to just go by ones. All right, so I'm going to go 2, 4, 6, 2, 4, 6, 8, and 10. Okay, and then our bin width, we want to be the same, just like a bar graph. Right, so if we want 2 or 3, grid squares wide, we need to be consistent with that. We have 7 bins that we're going to make. So we're going to go ahead and go by 2s. Okay, so this would mark, so this would be 70, 50, 70. This is your 90, your 110, your 130. Your 150, your 170, and your 190. And now remember, I'm not graphing the individual data points. I'm not graphing these individual data points that are listed up here. I am graphing how often I see data points that fall in those ranges. So between the 50 and 70, remember we're going to go conventional and take the 50 would go in the bin to the right, 70 would go in the bin to the right. So between 50 and really 69, we saw 3. So there's our first bar. Between 70 and 89, we saw 4. So there's our second bar. 90 and 109, I saw 9. So I draw it just like a regular bar graph here. And then I had 0, 0, 0, and then I had 1 in that 170 to 190 range. And so that is what our finished histogram would look like, right? And that's it. That's all I have. Now there's information I could pull off this. Like, for example, maybe I only had the histogram. Maybe I only had the picture. Well, I could figure out what my sample size was, right? I know that this bin, so I know that 3 data points fell in that bin, 4 fell in that bin, 9 fell in that one, 0, 0, 0, 0, and 1. So I could add those together, right? And I could determine my sample size of 17. I can look at that and make some estimates, right? That, where average would lie. Average would probably it might actually lie in this bin because of this big outlier out here. Okay, median, I can determine where median would be, right? If I have 17 points in total, okay, I have 7 of them are over here, 1 is over here, the other 9 are here. So my middle point's going to fall in this bin somewhere. My median would be in that range somewhere. Okay, so I can This data is skewed. I can determine shape, right? I can come across like this, and I've got a tail way over here. Okay, so this bin would have a little bit of a right skew to it. Okay, I put my right toe down, my right foot down, and my big toe would be where the peak is. So there's a variety of other information that we could pull if we just had the histogram. Remember, the only thing I cannot pull is if I just had the histogram, I would not know. Okay, one year we had exactly 74 metals. That's the information I cannot pull. So we could set this up as a relative frequency histogram as well. So looking at percent. So we would want to set up a table again to be able to build our graph from. So I have the same data that I had in my graph before. I'm going to go ahead and keep my bins the same. And I'm going to go ahead and label those out. And my frequency is still the same. My frequency is helpful in determining my relative frequency because what I need is I need a total, right? And I'm just looking for percent, right? So my relative frequency here is going to be 3 over 17, right, times 100. So this one would be about 17 point, let's take it 2 decimal places. And so I would do the same thing for every single one to determine my relative frequency at that particular level. So 23.53, oops, 9. Thought I was already at the zeros. So 52.94. 0, 0, 0. And these should add up to about 5.89. Right, these should add up to 100%. Right, so now I have a relative frequency table. Right, so now I know the percent, right, because that's what relative frequency tells me, my percent. So now I need units on my y-axis, right? Relative frequency, we did it in percent, right? I'm still looking though at the number of US metals. My x-axis is going to look the same, right? There's my 50, 70, 90, because I'm still graphing the number of US metals. What changes now is my y-axis, right? Because I'm doing percent, and I need to be able to get all the way up to about 53%. So I need to determine my scale on my y-axis. Okay, so in keeping our scale easy, we can go by fives, and we will fill the bulk of our graph. It won't be too jammed up too close together. I'm not looking for, like, let's do a scale of 3.2 or something, right? I would just want to, kind of a basic scale here. So 17.65, so 15, let's go about there. All right, and then 23.53. 52.9. And you'll notice that the shape of my graph is about the same as it's the same as it was before. Okay, it's just the information that's on my y-axis is different information, right? Whether it's the percent relative frequency or the actual frequency. Okay, but otherwise my graph looks the same. Okay, so that's how you would build a histogram. Okay, and then we would read them. So now you can, there's some practice questions as well as some practice standard deviation questions. So just a couple reminders about standard deviation, right? So remember, standard deviation is our typical distance a data point is away from the mean. Not the median, but the mean. If our data has a normal distribution, right? If our data has a normal distribution, that's when we can get that curve, that bell curve, right? That looks like that. right? Where that's our mean in the middle there. Remember, mean is X bar, that's my mean there. And then I go 1 standard deviation, 2 standard deviations, 3 standard deviations. All right, so this is +1 standard deviation, +2 standard deviations, +3 standard deviations. I also can go -1 standard deviation, -2, and minus. And when I create that there, my data points are going to fall within my data points that fall within 1 standard deviation. My data points that fall within 1 standard deviation, that's about 68% of my data points. About 95% of my data points fall within 2 standard deviations. Right, that's about 95% of my data points. So if my mean, let's say my average number of metals was 92 so my mean is 92 and my standard deviation is 8. Okay, so 95% of my data points would fall between the mean plus and minus 2 standard deviations. So in this instance, I'm going to come up here so I have more space. 92 plus or minus, my standard deviation is 8, so 2 times 8. So 92 plus and minus 16, right? Which gives me on the low end, right? So I've got 92 minus 16. So on the low end, I've got 76. On the high end, I've got 108. So 95% of my data points would fall between 76 metals and 108 metals, right? And when we go out 3 standard deviations, 99% of my data points fall within 3 standard deviations. So the mean plus or minus 3 standard deviations should include 99% of my data points. Something is considered an outlier if greater than 2 standard deviations above the mean or less than 2 standard deviations below the mean. So values that fall out here and way up high here, we would question some of those. We would possibly question those when we are doing our experiments. Maybe something went wrong in our experiment, but they are technically considered an outlier. Okay, so again, real quick standard deviation review. Go back and look at your M&M lab, as well as ask your questions.